Hello, learners. Greetings of the day. Today we'll be discussing the topic trigonometry and trigonometric ratios. So let us begin with today's topic. Let us try to understand what is trigonometry. Trigonometry is the branch of mathematics concerned with the sides and angles of a right angle triangle in geometry. As a result, trigonometric ratios are assessed in terms of sides and angles. What is trigonometric ratios? So, trigonometric ratios are defined as the values of all trigonometric functions based on the value of the ratio of sides in a right angle triangle. For instance, take for example, this is a right angle triangle, right angle at angle B. That means angle B is of the value 90 degree. The adjacent side or the angle opposite to this 90 degree angle, angle C that is considered, let this be angle be considered for which we have to calculate the trigonometric ratios. So then the angle, the side opposite to this angle C is known as the perpendicular side. The side opposite to the right angled side or the right angle is known as the hypotenuse. This is the longest side, and the side adjacent to the angle C is known as the base. So we have basically three major sides: hypotenuse, base, and perpendicular. So there are total 6 trigonometric functions altogether. These are sine, cosine, tangent, cosec or cosecant, secant or sec, and cotangent. So let us know how to calculate the values of these trigonometric functions. So as discussed, we have major sides in a right angle triangle. So let us discuss once again. So there are three major sides in a right angle triangle. Let us know them. Consider a triangle ABC which is right angled at angle B. That means angle B is 90 degree as shown in figure alongside. So there are three sides of the right angle which are the side opposite to the right angle, that is the hypotenuse, or it is denoted by H, hypotenuse, and it is denoted by capital H. The side adjacent to angle C or angle theta is known as the base, denoted by capital letter B. And the side opposite to angle theta is known as the perpendicular distance or the perpendicular, denoted by capital P. So you see there are three sides now: AC being the hypotenuse, BC being the base, and AB is the perpendicular height or the perpendicular distance. So these are the three sides: hypotenuse AC, perpendicular AB, and base BC. So let us now understand an analogy to remember the formulas for calculating the trigonometric ratios. So this analogy is: some people have curly brown hairs turned permanently black. So you have to consider the first letter of each word to calculate the trigonometric ratios. For example, sine theta or sine theta will have the value of perpendicular upon hypotenuse. So it is the ratio of perpendicular to the hypotenuse. Similarly, cos theta will have the value as the ratio of base to the hypotenuse, b upon h, and tan theta will have the value perpendicular upon base, p upon b. So there are another analogy also which you can use to remember this formula. It says Pandit Badri Prasad Har Har Bole. So this is another simple terminology in a Hindi language which you can easily remember, so that you can remember formulas for the trigonometric ratios. So let us continue our discussions. So basically we have seen that there are that the first trigonometric ratio or the trigonometric function is sine theta, cos theta, tan theta. So these three are known as the primary trigonometric functions. These are known as the primary trigonometric functions: sine theta, cos theta, and tan theta. And cosec theta, sec theta, and cot theta are basically the derived trigonometric functions. Derived trigonometric functions. Why? Because these trigonometric functions are derived from the very basics or the primary trigonometric functions. So because cosec theta is nothing but the reciprocal of sine theta, sec theta is nothing but the reciprocal of cos theta, and cot theta is the reciprocal of tan theta. So you see, we have calculated the uh, basic trigonometric functions. Now let us use them to solve a problem. So this problem here is, we are given a trigonometric function for the angle A in this triangle ABC, and it is given as tan A equals to 4 by 3. Okay, as per the, according to the question. So since we do not know that what was the length of the side, and it is a ratio, so let us consider that it was multiplied with a positive number, and let the sides be equal to 4k and 3k respectively. Okay, so according to the question, that means and since we all know that tan theta is equal to the ratio of perpendicular to the base, so this 4k will represent the perpendicular height, and 3k will represent the base height or base distance. So as you can see in this figure also, we have marked BC as 4k, or the angle, or the side opposite to the angle A. This is angle A, and the side opposite will be the perpendicular distance, and it is marked 4k. Similarly, the adjacent side of the base to angle A will be 3k. So now let us calculate the hypotenuse. We do not know the hypotenuse, because if we have to find the other trigonometric ratios for angle A, that means we need to know the hypotenuse, because sine theta is perpendicular upon hypotenuse. So how will we calculate the hypotenuse? We'll use the Pythagoras theorem. So by applying Pythagoras theorem, by applying Pythagoras's theorem. So what does the Pythagoras theorem say? It says that the hypotenuse square is equal to the square of sum of squares of the remaining two sides. Okay, so the square of the hypotenuse is nothing but the square of the sum of the squares of the remaining two sides. So perpendicular square plus base square. So if we calculate the hypotenuse AC in this case, as for the triangle ABC. So for triangle ABC, if we have to calculate the hypotenuse, that is AC, so we'll put this in the same equation as above by using the Pythagoras theorem. So we'll write AC square equals to BC square plus AB square. That means AC square is nothing but equal to the 4k square plus 3k square. Now AC will be equal to, if we take the under root on both sides, so we'll get square root. Taking square root on both sides, square root on both sides, we get AC equal to 16k square plus 9k square. So this will be under root of 25k square, and simply we'll get 5k. So we get the AC, or the hypotenuse value for this triangle ABC, as 5k. So now we know that AC, the length of AC is 5k. So now let us calculate the ratios. Like for example, if we have to calculate sine A, sine A will be equal to perpendicular upon hypotenuse. So perpendicular is 4k, hypotenuse is 5k. So we get the ratio as 4 upon 5. Okay. So calculating the cos of angle A, cosine of angle A, we'll get base upon hypotenuse, and base is 3k, and hypotenuse is, as we have calculated, is 5k. So we get 3 upon 5. Okay, so tan we already know. Now let us calculate cosec A. cosec A will be equal to hypotenuse upon perpendicular, because it is the reciprocal of sine A, or you can simply say 1 upon sine A you can do. Okay, so sine A we have calculated as 4 upon 5 previously, so 1 upon 4 upon 5. So we get 5 upon 4. So this is the value of cosec A. Now we calculate sec A. So sec A is hypotenuse upon base, or we can also say that it is reciprocal of cosine of angle A. So this will be equal to the 1 upon 3 upon 5. So this will be equal to 5 upon 3. Now we have to calculate cotangent of angle A. So cot A will be equal to base upon the perpendicular. Okay, so base upon base was how much? 3k, and perpendicular was 4k. So 3k upon 4k. So this will be equal to 3 upon 4. So these are all the required answers to this question, all the trigonometric ratios that we have found for angle A. Okay, so these are like, since we already knew tan A, and we have calculated using the Pythagoras theorem the third side of the triangle. So this way we can calculate all the trigonometric functions or trigonometric ratios of a particular angle. If we know any two sides, we can calculate the third side using the Pythagoras theorem, because it is only applicable to right angle triangles. Okay, so this way we can solve these questions. So I'm giving you a practice set of 4 questions. You can practice them, try at your own pace. Even if you don't get the right answer, don't worry. We'll discuss it in the class next time when we meet. So I want all of you to practice all these 4 questions. Make a notebook, write these solutions to these answers. At least you must try these questions. So I must be able to know how much you have grasped till from this lecture, and we'll discuss the solutions again in the next class. So, signing you off, thank you so much for listening patiently. Have a great day.